I believe it was over spring break of 2009 when naturally many of the students decided to go drinking and partying and traveling and all that good stuff. But I stayed behind and decided to take apart a bunch of antique computers that I had laying around. Some of them were, well, actually 3 of them were Toshiba 2200 laptops, and I got the LCD modules, or the LCD display panels. I saved them all this time, 5.5 years later, and here we are. Each display panel, like that, had attached to it a circuit board like that on that location, this location, and that location right there in the middle. 3 different ribbon cables that were soldered directly onto the boards. I've removed those, and off of these 3 circuit boards I've removed something else, and that is a bunch of these little smaller circuit boards, daughter boards, that are soldered directly onto them. Now I saw right away there's a VDD label right there, and a VEE right there, and then DC-DC. And we got a transformer coil, transformer ferrite core transformer right there, and a bunch of capacitors and some transistors and passives. So right away I'm thinking DC-DC converter. And I soldered some wires onto one of them so I could plug it into a breadboard and hook it up to a power supply and put a load on it and measure the output voltage. And I'm just going to crank the input. By the way, this is ground, 5 volt going in, and that's another ground. It's a straight connection between these 2 bottom ground pins on the circuit board itself. And the output right here, we'll see what voltage that goes up to. So I'm going to crank this up to 5 volts. And output negative 24.5 volts. Oops. Alright. So there we go. And the whole reason I'm doing this 5 volt input, it's quite obvious. Not only because it's coming out of a computer, but if the camera will focus, right there you can see on the input 100 microfarad and 6 volt capacitor. So certainly wouldn't want to put much more than 6 volts on that capacitor, on that input cap. And output caps, these 2 output caps on 33 volts. So right away I could tell that it was going to be a low voltage to a step up to a high voltage. Now as it is, this thing is maintaining a good 24 volts at about 23-24 milliamps going through that LED. If I short circuit one of these resistors, the LED brightens up a little bit, but the voltage goes down to 20 volts, negative 20 volts. So certainly not much more than 20 or 30 milliamps is what this thing can put out. But hey, if you need negative 24 volts at low current, you need negative 24 volts. I suppose it might have been used for driving the LCD, or the pixels of the LCD display on this thing. That might have been the whole reason why that thing was mounted on here, for providing a good negative voltage to get a nice AC swing for driving all these individual pixels. Now at first I wasn't going to do much more than just show this DC-DC converter as a whole, but I decided to reverse engineer it a little bit. So here's a good close-up view of it, and it's just a single-sided board. You can see right through the board to the copper pads, copper clad on the other side of the board, nothing on the back. And I took a picture of this and put it in the computer and flipped it and did some image processing, and what I came out with was this. So there's a layout of all the parts as you would see them looking looking from the top down, and here's the transformer and a bunch of other resistors and capacitors. This couple of inductors right here, these two little blue things, that one with the 100 right there in the top corner, and the 221, that's a 100 microhenry and 220 microhenry inductor, just in series with the input and the output. Then of course we got these large capacitors, and we got this one right here, high frequency shunt to ground, and all the semiconductor stuff right down here. Question mark means I'm not really entirely sure if these things are correct or if they exist. For example, this diode right here within the package, I'm pretty sure this diode has to be here, but this other diode within this 3-pin package, I'm not entirely sure if it exists or if it's needed. And this transistor right here, or this 3-pin package, I'm pretty sure it's an NPN transistor in this orientation, but could be a PNP, could be something else. But when I traced out a nice schematic like this, it seemed to fit just right as a PNP transistor, that, or NPN transistor. That's this one right down here. Here's that other mystery diode, and also I'm not entirely sure about the polarity of the primary and secondary coils of the transformer. If I put a dot down here, on the primary, the secondary dot might be here, it might be up there. Don't really know for sure. It's not really that important at the moment. I just want to get a basic understanding of how this thing works. Okay, so 5 volts coming in, bunch of DC filtering here, and then that goes straight to transformer coil and then to collector of this transistor right here. That's this big beast of a transistor right here with 3 pins on the bottom and the tab on the other side. That one gets some DC bias through this 1800 ohm resistor, and that of course, once current comes down here, that gets current flowing through the transformer, and then that's going to, current rising through here is going to make a voltage rising on the other side of the transformer. And then there's feedback here that feeds back into 100 ohm resistor and AC coupling back to the base of the main drive transistor. So I'm not really entirely sure of the exact scheme and timing diagrams of what's going on here, what kind of voltage or current controls what other kind of voltage or current going through here. Anyway, it's a self-oscillating circuit, just this portion right here. That's all you need to worry about, and that would be all you need if you didn't have to worry about regulation. Now of course on the secondary side there's the main rectifier diode right here, and flyback diode possibly existing right there, and then of course capacitor and inductor filter going out to negative 24 volts. The feedback for voltage regulation comes back down here to this Zener diode. If we can focus on this, that tiny little dinky thing right there, maybe the camera can make it out. There's a very faint 24 printed on there and a little bar on the top, so right away I was thinking that would be a Zener diode with a 24 volt Zener breakdown voltage, and that goes to supposedly the emitter of this one other transistor, and basically the regulation takes effect where if you just assume that the output maybe goes a little higher to a negative 25 volts, you would have a negative 1 volt right there. If you got negative 25 here, negative 1 volt there, and there's going to be small DC or a small voltage at one point during the AC cycle. You're going to have a small voltage here on this tap of the coil driving this transistor, and it's certainly going to be turned on. So if this transistor is turned on, it's going to pull the base of the main drive transistor down down below ground even, so that's going to shut this one off. And of course that would bring the output voltage back down to negative 24 instead of negative 25. And that's the basic gist of the circuit. That's all I'm looking for right now. We got input filtering, output filtering, the main rectifier diode right here, the main drive circuit right here with feedback for oscillation coming right here, and then the voltage regulation, output voltage regulation happening right here. There's a few details that are a little sketchy, but you know, you could easily breadboard this thing out of discrete components and see if you can get a very similar circuit like this working. So I don't entirely understand this circuit 100%, but if you wanted to fully understand it, you could always just build something very similar on breadboard and play around with some of these component values and semiconductors, whether or not they are actually in circuit at all. Then you can, you know, figure out this stuff for yourself. So that's a very rough reverse engineering job of a small DC-DC converter module taken out of a Toshiba 2200 laptop from the early 90s, about 1991. And if you learned something while watching this video, then please give it a thumbs up. Thanks for watching.